We are discussing about the topic is turbine. What is turbine? A turbine is a rotor mechanical device that extracts energy from a fast moving flow of water, steam, gas, air, or other fluid and converts it into useful work. A turbine is a turbo machine with at least one moving part called a rotor assembly, which is a shaft or drum with blade attached. Moving fluid acts on the blades so that move and input rotational energy to the rotor. And working principle. The working principle is very simple. When the fluid strikes the blade of the turbine, the blades are displaced with produced rotational energy. When the turbine shaft is directly coupled to an electrical generator, mechanical engine is converted into electrical energy. This electrical power is known as hydroelectric power. And the types: water turbine, steam turbine, gas turbine, wind turbine. The same principle applied to all turbines.
Rotational energy. Traditional windmills use wheat pump or water, but in modern windmills, wheat pump or water pump turbines is generated that creates electricity. That's convention for wind to rotational energy to electricity has defined wind turbines since their innovation of 19th century. And there is a three primary factors that determine just how much energy that can produce: the size and orientation of the blades, aerodynamically designs, and the amount of wind turning that rotor. First up, blade orientation. Wind turbines can be designed that they rotate one of the vertical axis or horizontal axis. Vertical blades can pick up wind upcoming from any direction, but that's less efficiency than horizontal axis rotors. Horizontal designs allow blades to capture the wind full force by tracking the wind direction and turning to face it. This turning process is called airing, and older windmills achieved that through manually monitoring. Today, wind sensors and computer systems automatically adjust the blades with the expert precision to capture with much energy as possible. Outside rotor, orientationally the blades themselves needs to shape it of maximum efficiency. While earlier designs used that flat blades, modern blades are curved like a aeroplane wings. Wind travels faster over the curved surface, creating a low pressure pocket above the blades that forces upwards. Since the amount of left depending on the angle and which the wind moving relative to the blades, modern blades also incorrect. A twist optimizing how much blade can cut into the wind, made of fiberglass and precision layering. These blades are strong and enjoyed to operating through a lightning and blazing sunlight for over 20 years. Even with the aerodynamic blades and horizontal rotor, a wind turbine can only capture wind if it's widely environmental. Wind speed typically increase the higher into atmosphere to the travel. So today most turbines are with over 100 meters take tall with really large rotor diameters. A turbine too of the high and size can capture huge amount of wind generating. Enjoy electricity every year of per 750 American houses are wind farm 200. Similarly, size turbines could power over or 100 to 50,000 American houses are twice of many European houses are electrical year offshore. Wind farms contain even greater number of even large turbine. In 2019, the largest wind turbine ever building begins operating off the coast of Northlands with rotor diameters of 220 meters. Just one of these turbines can meet annually power needs of 16,000 European households. Deposits its amazing potential. Wind energy still faces challenges. Wind may be a free and unlimited fuel, but matter how large efficient turbines is mathematically limited how much wind can convert into electricity. German physicist Albert Beetz calculated that since some wind must remaining a keep blades spinning a turbine and only ever capture 59.3% of.
The principle behind the wind turbine is very simple. Energy in the wind turns the blade around the rotor. Rotor is connected to the shaft which spin a generation to the create electricity. In this video we will learn how wind turbine works and generate the electricity. The wind turbines has many components which electricity help in the generating electricity. The wind runs through the turbine's blade, decreasing the arm pressure one side of the blade. This causes difference the air pressure through the both sides of the blade and generating the force of the blade. The intensity of the force rotating the rotor but the slow rotation. Speed of the blade is not linked to the produced electricity. For this reason, a gearbox connected to between the rotor and the generator. This generator transfers to the aerodynamic force into the electricity of the housing holding gearbox, and the generation is called nacelle, which can move according to the direction of the wind. If the direction of the wind change, velocity sensor located on the top of the nozzle send the signal to the yawing mechanism at the base of the nozzle. This mechanism then move blades to the force of the proper wind direction. Also, blade can rotate using blade fitting mechanism to also itself with the proper angle of the wing. In this way, wind turbine can convert wind energy into electricity. Thank you for watching this video.